Hello everyone. This question has been taken from Olympiad Pathfinder. Multiple choice question number 18 from chapter 2, Newton's law of motion. In the question, three identical balls A, B and C, each of mass m, connected by three identical springs, when placed on a frictionless horizontal floor, occupy corners of an equilateral triangle as shown in the figure. This is the figure. A is the ball, B is the ball, and C is the ball. All three balls are attached by the springs AB, BC, AC. These springs are identical. It means the springs have the same spring constant. And when it is lying on the floor, it is forming an equilateral triangle. It means all the sides are equal. Spring size AB, BC, and AC all are equal. Now this assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. A light thread is attached to A and other end at the ceiling. With the ceiling it is hanged. So it is asking, what can you predict regarding acceleration of the balls immediately after the thread is cut? When the thread is cut, what will be the acceleration? Acceleration of free fall to be taken as g. There are four options. Like one is all the balls will have downward acceleration g. B is all the balls have acceleration greater than g in different directions. C is acceleration of the upper ball is 3g downwards and the acceleration of the lower balls are vanishingly small. Vanishingly small means almost zero. Acceleration of the upper ball is 3g downwards and the lower balls move apart with finite acceleration. But this answers to be found immediately after cutting the thread, means at the instant when the thread is cut. In this picture we have shown that this assembly has been hanged from the ceiling and this is the light thread. So what will happen? Your A is fixed to the rigid string, so this will not have any downward movement. But B and C will move because of the gravitational pull on these two balls. So because of this, because of the weight of B and C, spring AB and AC will elongate, okay, and BC will compress. You should feel it, that BC will compress and these two will elongate. Initially, the length of the springs AB and AC were the same and BC were the same. In solve it, all the lengths were L. So it means even after stretching identical string, so stretch in AB and AC will also be the same. So this AB and AC will be equal in length. So this ABC will take the shape of an isosceles triangle. Okay. For the convenience, we have taken the springs, this spring as A, this spring as B, and this spring as C. Ka is equal to Kb is equal to Kc is equal to K from the questions. Mass of ball A, mass of ball B, mass of ball C is equal to M from the question. Relaxed length of all the springs on the floor was taken as L. So now this has elongated, and this one is compressed. So elongation in AB spring, we have taken it as small s, the same amount by which AC will also elongate, and that is shown here. So this spring will become a length equal to L plus S and this will become L plus S. Since this is compressed, so we have assumed that this B spring, this B spring is compressed by Z amount. Okay, so this length has BC has become L minus Z. Okay, this angle B we have taken as theta, angle C we have taken as theta. So A angle as a whole will become pi minus 2 theta, right? And when we drop a perpendicular from A to BC, that is D, so this angle BAD, you should say BAD, will become pi by 2 minus theta, and similarly CAD will become pi by 2 minus theta. So now we will make the free body diagram of A, B and C, and we'll see. So here we draw the free body diagram of ball A. Okay. On ball A, if you see which all forces are acting, mg, that is weight of the ball, is acting. A spring force due to AB is in this direction, and that is equal to Ks from the Hooke's law. And due to AC spring in this direction, from A to this direction, and that also is Ks. Okay. And thread is exerting a force of T on ball A in the upward directions. So we have all the forces available on acting on ball A, and the ball A presently is in stationary condition before cutting the thread. So we have equated all the forces in the y direction and writing the Newton's law of motion equations. So summation of Fy in summation of all the forces in the y direction is mg, the downward force, ks sine theta, this one, due to this spring, downward, ks sine theta due to this spring, downward, minus t is equal to 0. So from here we got mg plus 2 ks sine theta minus t is equal to 0. And we have said it or named it as equation 1. Now we will go on free body diagram of ball B. So this is your ball B. So ball B is attached to one spring, that is BC, in this direction. BC is compressed, so spring force will be in this direction. Okay, that is kz. Weight is acting downward. Okay, and it is connected with AB, and AB is elongated, so spring force on B will be in the upward this direction along this spring. Okay, so this spring force is two component, ks sine theta and ks cos theta in the horizontal direction, x and y direction. So we also will write Newton's law of motion equation on ball B. So ks sine theta is this direction, minus mg is acting downward, ks sine theta is upwards. Okay, so this is equal to no acceleration initially, system is in equilibrium, so this is equal to 0. So ks sine theta is equal to mg, right? Now if we take the forces in the x direction, so ks cos theta, okay, this is ks cos theta, minus kz is acting in this direction, is equal to 0. So ks cos theta minus kz is equal to 0. So this is equation 3 we have assumed, okay, or we have named. The ball C, due to symmetry, will have the forces acting on it similar to as that of B. So we will not be getting any new kind of equations from ball C. So it is not needed to make free body diagram of ball C or write equations of forces on ball C. Okay. Now in the question it is giving when the system was in equilibrium and thread is cut after that. Okay. So what will happen when you are cutting the thread? You are losing the tension. Immediately the tension force will become zero, which is acting on ball A. So we have written already the equation 1 for ball A. So in that we'll have to put T is equal to 0. Because of this tension force getting 0, unbalanced force will come up on ball A. Okay, and the ball A immediately after cutting will accelerate. Okay, yeah, due to the unbalanced force. And let us say that A is the acceleration of the ball A just after cutting the thread, and that is in the downward direction. Okay, so equation 1 becomes, after putting T is equal to 0 and taking the acceleration of ball A as small a, so we can write our equation will become mg plus 2 ks sine theta is equal to ma. Okay, so our equation 1 has become this now. Ball B and C is nowhere connected with your thread. So cutting the thread, when the thread is cut, at that instant, forces on B and C will remain the same as it was before, only at that instant. So initially ball B and C were in equilibrium, right? Means there was no acceleration. So just after cutting the thread, also it will not have any impact on that equation. So acceleration of B and C will be 0, which we can say vanishingly small, means almost 0, right? Now from equation 2 and 4. 4 is your ma is equal to mg plus 2 into ks sine theta. Okay, and 2 was ks sine theta is equal to mg. So we have put ks sine theta value from equation 2 in this. So acceleration what we got is 3g in the vertically downward direction for ball A. Okay. If you see the forces on A in the x direction, all the forces are cancelling out, because in the horizontal direction, spring AB and AC forces are ks cos theta. One is acting leftward direction, one is acting in the rightward direction, if you go and see in the free body diagram. So in x direction there is no resultant force, therefore ball A will not have any acceleration in the x direction. So whole of the acceleration will be in the downward direction, that is equal to 3g. So we can conclude here that answer is option C. So hopefully you understood all the stages and all the steps. Anywhere if you have any doubt, you can write in the comment box. I'll come back with reply. Thank you.